Okay, good morning. We'll start with the lesson. In last class, I have told you that how on a sample NS2 program can be built based on the problem given and what are the common things which is there in that particular program which we have seen. And I have told you that I will show you the graphical user interface where automatically just drag and drop the components of a network, then automatically the TCL script will be built, and minor changes after going to the TCL script if you do, and you can run the program very easily. That tool is ready now, and I will demonstrate that tool also with the today's first lab program. Now, first we'll go with an lab program, and we'll study the question first. And we'll analyze the problem, how to analyze the problem, and how first the paperwork should be done before going to the NS2 program. That I will, with that particular first step, we will start today's first lab program of part B. Right now, first we'll go with the question. That is, I'll share first the manual, and later on we'll go one by one. So I'll come with manual, share this. Yeah. Now, we'll go to the program problem, just not on a program, just I need a problem here. Yeah, just, yeah, part B. Now, observe carefully, this is a problem. That is, simulate a 3 nodes point-to-point network with duplex links between them. Set the queue size. This is important. Set the queue size and vary the bandwidth and find the number of packets dropped. In a last session, just for an example, same 3 nodes only we have taken, and we have varied the bandwidth, and we have seen how, means for example 5 MB I have taken, and here 1 MB I have taken, that is from N0 to N1 5 MB, and from N1 to N2, which is destination, we have taken only 1 MB, that is 5 MB of data from sources coming via N2 sorry, N1. From N1 it has to go to N2. N2 is a destination, but N1 to N2 it is only 1 MB, and we have seen that simulation also. Here there is a gap between packets, and here continuous line is going on in a simulation also we have seen. Now, what is the problem? First, you analyze the first thing here. What we have to analyze the first thing here? Simulate a 3 nodes point-to-point network with duplex links between them. So this is a first step. That is, you must have a 3 nodes, that is N0, N1 and N2, and a duplex link should be established to them. Set the queue size, means we have to set the queue size. You know how to, means drop tile queue, how we are taking in just the duplex link only, and then how to set the queue size I will tell today now. And vary the bandwidth. This is very much important. It's telling that like that, and we have to vary the 2 bandwidths. and we have to see how many means packets will drop. Either here, according to the problem, that here E is not at all mentioned about any traffic. That is either TCP you can use or either UDP you can use. Not at all a problem here. So that is a problem analysis. So how a problem analysis and means how a topology should be drawn. Now what you have to do, you first take one notebook. Everyone, please take one notebook. Take a notebook. Taking a notebook, first you have to go with the problems. That is just what I will do now. I will go to the paint. I don't have a notebook here in online. Because of that, I am going for a paint. In notebook, whatever now I will do in a paint, you can do that, right? Now go back here. Just 1 minute. I'll select it. Right. Now, three nodes must be there. I will take a first node, same, that is N0, as I told you that. Let it be N0. And I will take another node, that is N1, just for a sake, I'm taking here, right? And I'm going to take N2, right? To another node. Right. So three nodes I have to take. This is there in a problem. Then I have to set a duplex links. That is, a link must be established from N0 to N1 and N1 to N2. Right. So this should be in a duplex links, and the time you can give according to your will. So vary the bandwidth. They have told very clearly. You must keep in your mind. Vary the bandwidth. They have told. So vary the bandwidth means we have to take some 2, 3, 4 bandwidths like that. Now here observe carefully how I will take a bandwidth.
So we cannot see the paint. So
You can't see.
yes, sir. We can see only the document.
Why?
The word.
I'm writing no.
No, sir. We cannot see that.
Oh. Then what we can do?
So you have to close this and open that. So like
Which one?
close this presentation and open that presentation.
Yeah, open. No, I have closed this. 1 minute. Wait. Now I closed. I'll come back here. Just a minute. Just a minute. Again, I will share the window. Oh, sorry. Just again, I will share the window. Yeah, I should open Paint now. Correct? No.
Yes,
Right.
yes, sir.
Okay. Now you can see. Hello.
Yes, sir.
Yeah. Now, as usual, I have told you. I repeat once again. So what I made here, just in a book also, you have to do same thing. So first you write the three nodes, that is N0, N1 and N2. According to the problem, you have to create three nodes, point to point network. This is very important. Point to point. That is one-to-one connection you have to establish. So write one-to-one connection. That is N0 to N1 and N1 to N2. This must be a duplex link. So this must be a duplex link. In a pen, you can write down here if you want. That's a duplex link. Means DUP, LEX. You can write down. Not an issues. Then what is the next thing in a problem? The next thing in a problem is you have to vary the bandwidth. You have to vary the bandwidth, and you have to set the queue size. And after setting a queue size, you have to vary the bandwidth. This is there. Now observe carefully what according to me I'm going to do here. From N0 to N1, whatever a queue is there, I will set the queue size. Everyone observing carefully, I will set the first queue size is equal to, for example, 20. What do you mean by this 20? I will set the queue size to 20 means maximum 20 packets it can hold in a queue. Now same thing I will come over here, N1 to N2, I will set a queue size, that is I'll call it as a Q2, and I will set it as a for 20 only. Imagine I'm setting same queue size. They have told set the queue size. That's it. They have not given any number in a problem. So according to us, we can set the queue size. There is no thing. Coming to the next thing. What the next thing they have told? You fix the bandwidth and vary the bandwidth accordingly. After varying, you must check how many packets has been dropped. This is important. Now coming to the moment scenario here, what a bandwidth I will take, observe carefully. I'll start with 50 MB. N0 to N1. Everyone listening, any doubt you can interrupt me, not an issue. So 50 MB and I will take 10 milliseconds, just 10 milliseconds, right? So this is a one thing I will take. When it is 50 MB, here I will take 1 MB, 1 MB. This is in real time, it will be like this always. 1 MB and 10 milliseconds, right? Now again, vary, they have told vary. So we'll check for some three values at least. So then again here I will take some 100 MB, 100 MB, 10 milliseconds, 10 milliseconds. Let it be 1 MB only. And then we'll check how many packets are dropped. Means double should be dropped, right? According to us. Right. Now third value I will take here some 150 MB, 150 MB. In a paper you can write easily, I think, but here I am feeling somewhat tough. 10 milliseconds. I am not changing. Here they have not told about time constraint. So here I will do 2 MB. 2 MB. Now I think remaining thing you can take it. So 10 milliseconds. 10 milliseconds. So for these three values will work out. Now this is not only the simulation will run, we need a traffic also. In a problem they have not told traffic, either traffic you can take, either UDP you can take, either TCP you can take, it's left to you. So either now we will take a TCP. Why? Because in the last class we have taken TCP. Now we'll take. Now we'll decide N0 is a source and N2 is a destination. First you have to decide. This is very much important. So once if you have decided N0 as a source, then the first thing is a transport agent should be fixed to this. What is a transport agent? Let it be TCP0. That object you should define with a class called as TCP. Let it. Then afterwards, once you have gone with this, you should go with an application agent, that is a FT. If TCP is a transport agent, then compulsorily FTP will be the application agent. That you have to keep in your minds always, right? Then coming to the destination side. Now here it is over. Coming to the destination side, only transport agent will be there, no application agent. What is a transport agent you have to fix here? If TCP is a source transport agent, at the destination side, TCP sync will be the agent. So that you have to keep in your mind. That is sync. I will write sync. Right, sync. Now you should establish a virtual connection. As I told you, you should establish a virtual connection from TCP to TCP sync. That is connect, right? Now this is the one thing which it has been done. Finally, you have to run the simulation. How you are going to run the simulation? I will call this entire simulation as a NS. I'll give a name NS. I will start the simulation of FTP simulation. I'll start, at 0.0 second, right? And I will stop FTP flow. Assume that 9.9 only. The last thing we have taken 9.9 only. Then total simulation end. That is end will be done with 10 seconds. So total simulation. Now simulation is ready. Finally, you have to run the simulation. Don't forget the run statement. Now, if you write in a paper like this, definitely 100% you will be succeed in your program. So doing as it is going to the NS2 softwares, it's not good. So once if you draw all these things in a paper, you never forget anything. So all the concepts are there here according to the problem in this particular, according to me, it's a paper, right? So in this paper, I have set the queue size and I have set the duplex lengths, I have set the bandwidths, what to take, the varying the bandwidths, I have set the traffic, so I have set the simulation time and I have set the end simulation time. Finally, run also. I shouldn't forget that also. Total simulation I'll call with the name called as NS, that also have decided. So if you do like this, you never forget any of the concept. Right. Now I'll stop this sharing and we'll go to the software, how you are going to do the program. Right. Uh, Stop this. Now again, I'll go to the VMware. Sorry, before going to the VMware, first I have to share that. Now, share the window. There is a VMware. Yeah. Now I'll share this particular. Now observe carefully. This is a NSG 2.1.jar file is there. This is a one animation means GUI, graphical user interface for an NS2 where you can generate a TCL scripts. This will be available, this jar file will be available in a net. It's a free, it will be available as a free. You can download this. If you type nsg 2.1.jar, automatically it will come. What is the condition here? In your Linux you should have Java 6.1 above versions always. If you doesn't have a Java 6.1 above version, it never jar file never be shown with this coffee icon. Means you can see here, once it has shown this coffee icon, then that means that you can run this particular jar file. That you have to keep in your mind. I am telling very clearly. Now I told you how to install a NS2 2.3. Correct? No, means 2.34. After installing a NS2 everything, what you have to do? You have to go to the internet. There you type NSG 2.1 dot jar download. Then automatically you can download that. Once if you have download that, think that Linux means Java is not there in your VMware. Just for a sake, I'm telling. If it is not there, what you have to do? Java is also free. Then you go and you type Java 6.1 or 2 version for Linux. This is very important for Linux. Then RPM file will be downloaded for you. RPM file will be downloaded. I will show you the file also. If you want, see here, this is a file. This is a RPM file, JRE6U. This is 3.1 version, right? Linux for 586. So this is a 32-bit thing we have taken. Either you have to decide that's 64-bit or a, sorry, this is 64-bit. This is a 64-bit we have taken into the consideration. Now you have to check this. JRE, this particular RMP file, you have to download. This is also free. See what is the softwares I am using here. All the softwares are free. You can download easily from a internet. So after downloading this, just double click on this. Automatically it will install RMP files. It will install, it's an installer. It will install automatically like Windows. Just double clicking on that. It will ask you some suggestions. It will, means setup. Once if you click on a setup, it will be installed. Once it has been installed, there is no need to install this. This downloaded file is a file, jar file. So automatically this jar file will be there. Means this jar file will be converted into this coffee bean symbol. This is about the NS means 2.1 jar file. Now how to do the program in this, I'll tell you. Now open with Java. Always if you double click on this, archive will be opened. You don't want to archive, you have to run that. Let's see, if I double click on that, archive will be opened. I don't want this, so I have to run this. What I have to do, right click on that, open with Java, you have to click always. Now open with Java, if you click, then automatically a graphical interface file will be opened to you. Now see, this is a editor which has been opened. Now go to the system here. First you check. If you click exit, it will come out. Now come to the scenario. See, in scenario, two types is there. That is a new wired scenario, new wireless scenario. Window is there. That is iconify all, deconify all, close all. Means whatever a windows, sub windows and all you can create. But no need of that actually to say. But always within a new wired scenario. All your NS2 programs are a wired programs. Because of that, you can go with new wired scenario. Once if you click on this new wired scenario, are you seeing here everyone? If you click on this particular thing or this file draw mode, everything will be opened to you. Once it has been opened, then what you have to do? That is, you are there at a node. You can see single node will be there here, or you can take vertical chain, horizontal chain, or a grid, or an a random. A link type also you can take, agent also you can take, what is the application agent you can take, and what are the parameters you want to fix, you can fix this. And coming to your hand, here this is the hand means this is a layout. So there's a hand. Now coming to your node, I will click on a node. I will take yes. I need a single nodes, which I have did in a painting like that. Means painting software. How I did like that. I will take a single first. I will create a nodes. Let it be first node. That is N0. Let it just click. Take a mouse pointer. Just click. Automatically node will come. So next will be N1, and next another one I want is N2. Now nodes are ready with me. Everyone, notes are ready with me. If any doubt, you can interrupt me, not an issues. Then I'll go with a link. Now observe carefully. Link type, duplex link. What problem they have asked? Yes, it's a duplex link only they asked. What else other links are there? Simplex and a duplex. That means one-way connection or two-way connection. I need a two-way connection. Now observe everyone. Q type. Q type is a drop tile. It's a default one. Let it be. Why? Because in problem they have not specified a particular queue. So default queue only will take. Now capacity. This is very much important. You can see the capacity of that particular queue. 100 Mbps, sorry, capacity of that particular link, bandwidth of that particular link. Now in our paper, what we have did, the first bandwidth will be 50 Mbps. Correct? No, everyone listening, 50 Mbps. Now propagation 10 milliseconds. It's correct. Now coming to the queue size. Queue size we have decided not 50. We have decided it is 20. Now this is ready according to our plan. Now what we have to do here, just click on N0 and drag this and click on N1. A link is established. That's it. Very simple. First you have to click source and you have to click the next node. Once if you click, means once if you click here, it will become a green, then that means yes, ready. Now you click the end node, automatically link will be up. Again I will show you once again. Now again we have to create a link from N1 to N2. Now observe carefully, there also link type is a duplex link, right? And queue type is a drop tile queue, okay? Queue type is also okay. And bandwidth we have decided that it's a 1 Mbps, right? And delay 10 milliseconds only, and queue size is 20 only. Just we have to change the bandwidth to 1 Mbps. Now observe carefully how to establish a queue link between N1 and N2. Just click here, that's it. Just click there, green color it will come, then automatically click on N2 and link will be created. Now it's ready. So whatever queue size they have told everything, with that it is ready. Now next thing what you have to do, the next thing is, you know, that it's a traffic. Now we have decided the traffic will be a TCP. Observe carefully, the traffic will be a TCP. Now yes, TCP we can take. What else are there? You can see, have a look here. TCP and different versions of TCP is there, UDP is there, and a null agent is there, and a TCP sync is there. If UDP is the source, null will be the destination. If TCP is the source, TCP sync will be the destination. Now according to our problem, we will take TCP as a source transport agent. Let the packet size be 1500 bytes only, not issue. If you want, you can change that. Just I'll click on here and drag this, click on that, green color will come, drag that, just click there. Now observe TCP 0K. Are you seeing there? Any doubt you can stop there itself, right? So this TCP have created. Once the transport agent I have created TCP for a source, I know that the destination for my topology now is N2. At a destination side, if TCP is the source, then automatically TCP sync will be the destination agent. Now you click on this and drag it and you tell right. So finally what you have to do, you have to connect from, this is very much important, you have to connect from TCP to TCP sync. A virtual link will be established, you can see in a red color, right? So a virtual link will be established. This is end-to-end process will be done by TCP 0 and sync 1, that you have to keep in your mind. Now only transport layer is not enough at a source to generate the data, you need an application agent, sorry, application agent also. So how an application agent, if TCP is the transport agent, compulsory the application agent will be FTP, right? So you let it be FTP. Start time, what is this? Means start simulation start time. It's there here already. So what you have to do? I told you that it's not 1, 0.0. Give 0.0, not an issue. Stop time, we have decided that 9.9 FTP card, right? So just you click on TCP. You have to click on TCP, not else otherwise. On TCP transport layer only, application layer will come. So just click there, drag this. Now over. Our topology we have did, everything we have did. Then observe carefully, go to the parameters. Now total simulation, how much time you want to set? Default it is 10, and out.tr is a trace file, nam file, out.nam it's taken. So if you want to take, for all programs it will take like that. If you want to change your program by program, means assume that program number 1 you want to give for your identification, just I mean to tell. Now you can change your the name. For understanding of you, I'll do it this as prog1. For prog1.tr, and I will tell prog1.nam. Both nam and animator output and trace output have saved, right? So then I'll tell done. Now parameters also set. Everything is set now. Now I will click on TCL. It will generate a TCL script. Just click on that. Now you can see here a code. How beautiful it is. Right now, how beautiful it is. Everything is there here. I'll explain you the code also. What we did in a last class, which I did with a manual type. Now everything automatically it has been generated. No need of any further even finish function. Everything is generated here. Now what you have to do, another one important thing is save. If you doesn't save, it will be not there. So save this first. So where? In root only, or if you create one folder, go to that folder and you can save. What you have to save? I will save prog1.tcl. Right? .tcl is must. Don't forget that. Save. Now it has been saved. Then you close the program. You close this particular NS. Now it's saved, and you can close this NS. Now go back to the terminal. Now you tell gedit what the program you have created with the editor. That is prog1.tcl. Enter. Now observe the code it has opened here. Am I right? Everyone, are you seeing here how the code it is opened? Set val of is array. As I told you, you know this. Val is an array. So index will be stop. So it's a 10. Now you can see set ns new simulator. There is no need to create same thing. What I told, everything will be same. But statements will be here and there. That's it. Now you can see set s new simulator, set trace file. Are you seeing here? Open prog1.tr. There we have set the name. Trace all is a command, right? Set nam file. prog1.nam, open in a write mode, and nam trace all, it is there here, automatically command came. Then finish function, as I told you, finish function is defined in a below here. See, it has been defined in a below. If you want, you can take it up, not an issue, it's left to you. Before calling, you have to define that side. Calling, it has been done here, that's why they have made here. Not our issues. So if you want, you can take this above. That is proc finish, global, NS, trace file, NAM file. You can see that. And then flush trace, close trace file, close NAM file, execute NAM, prog1.nam. Same. Not even a single instruction it has been changed. Now you go back. Actual, it is a common things I told in a last class. Now, according to the problem, three nodes created automatically, duplex link from N0 to N1, 50 MB is there, and 10 minutes done, queue limit 20 it has been set, and everything is set there. Then even node position also you can orient it, means where should node position should come. That you can do any in NAM editor, that's why that I didn't told you. Coming to the next, you can see here, set TCP, how automatically it's created, and $ns attach agent N0 to TCP, then set sync 1, then automatically TCP sync attach that to N2, connect TCP 0, and observe dollar TCP 0 set packet size, automatically packet size has been set. And you can come down here and you can see the FTP connections, application slash FTP, how agent FTP 0 is already created, dollar FTP 0 attach that agent to dollar TCP 0, then automatically schedules how it is there, $ns at 0.0 you start FTP, and 9.9 stop FTP. How? Then coming to the next, you can see here value dollar value dot stop. So what is there here? Stop means there we have defined in above the array index has been defined with 10. Correct? No. At that time it is going to end and it will call the finish function. That's it. So how beautifully the code has been generated by automatically, you can see. Now you have to run this particular. That's it. So close this now. Right now run this. NS log 1 dot TCL. Right now press enter. Yes, we got it. Let it be. Yeah. Now 0, 1, 2 nodes are there, and you know that default it will be 2 milliseconds, and you can start now the simulation. Start. See here, it started. So what we had given here 1 MB and there 50 MB. So any packets will drop, you can check it out. Drop means it will drop significance, it will show here. I will show. No packets drop. So then what you have to do? Starting still you have to give more, or you can reduce this here. That is, for example, this is a simulation. It will be like that always experimenting. So close this now again. Come back here. So just sorry, Control C. Control C. Yes. Now again, gedit. Go to the program. Now in this program, come back where a bandwidth is there, right? Now we'll start with 100 itself. We decided 50, 100 and 150, right? Now I will start with even 100. Just I'll check now again. Save this, close this. Now again you run this. Let it be this on taskbar. So again you run this. Um, right? Now again we got this. Now again run this. So what I've made 100 MB, correct? Oh, still it's not dropping. drop here, drop packets you can see. Then else we'll go with further. Go back, come here, just a minute. Yeah, bandwidth is there here. I will do this 0.5. Save this. Close. Again run this. Okay. No dropping because of our queue size. It's there and system fastness. Just one. Go back again. I will come here. I'll set it 500. Save this. Close. Now, yes. I'll run again. Just 1 minute. Go back. Reduce this to 5 milliseconds. 0.5. So close again. Now run again. I think here we are not able to see. Okay, we'll check in AWK at least. Close this. Okay, wait 1 minute. We'll go with a trace file, whether it's created or not. We'll check first. prog1.tr. Right. Now gedit prog1.tr. Sorry, prog1.tr. Right. Now press enter. Now here somewhere D is there. Cross check it. Let it be. Now, see what is the intention here according to the program, what I have told very clearly. That is, you vary the bandwidth and check how many packets it has been dropped. Now here, in our case, 500 MB is a bandwidth first we have given from N0 to N1 and N1 to N2 0.5 MB we have given and 10 milliseconds and a 5 milliseconds here. Now we will check how many packets here it has been dropped. Then how we can check using an AWK script that you have to keep in your mind. How AWK script you can use here? Observe in a AWK script, I think you have did Unix already. In AWK script, each column will be represented as $1, $2, $3, $4 like that until $n. The file name will be represented as $0 that you have to keep in your mind. Now $1, the first column, it must be D, means the letter must be D. I want a lines where the first column letter must be D. If it is D, then I will increment the count variable. If it is D, I will increment the count variable. Otherwise, I never increment the count variable. Then how many D's are there in this particular lines? I will get automatically. Now, just how I am going to do this AWK program, you can see this. This must also be there here. That is gedit prog1 dot AWK, right? Go to there. Now, what you have to do here, first type the program. You know this in AWK, beginning will be there, begin. I'll start here. So as you know this already, that I'm going to use a count variable. I'm going to initialize that to 0. Sorry, let it be 0. Right? Close the beginning part. Then you know that body part will be there. Now come to the body part. In this entire body part, what we have to do, I have to check if the first column, whatever is there, if it is equal to D, I should increment count. That's it. That is if if the condition, what is the condition here? $1 first, sorry, $1 first column is equal to what is that? D. Then count plus plus. Close this. Then close the body. $1 is equal to D. Then count plus plus, close the D. Correct. Now entire body we have closed. Now come to the end part. That is end. Now in the end, what you have to do? You have to print. That is print or printf also you can use. That you know that. So print the number of packets dropped is, close this, comma. So what is the variable? Count. See, count. That's it. So save this. If you're not following, you can ask me. What I did, you know AWK already. According to me, I'm thinking like that. Why? Because you studied in Unix. So 3 parts will be there. Beginning part for initialization, then body part, where body part, each line from an input file it will take and it will do these instructions. First line it will take and it will check either in column 1 D is there. If D is there, count plus plus. Second line it will take like that, all lines it will filter. Next, finally, after doing this, at the end, what we are going to do, we are going to print that particular count variable. So this is there, and then I'm closing the end. Save this. Now close this. You run this AWK. How to run? You know this already. AWK option F to run the file. Then you give AWK file prog1.awk and input file you have to give. What is the input file here? prog1.tr. Don't forget that. tr is the input file. That is a trace file. Now press enter. Yes, see the number of packets dropped is 0. It's not at all dropping, and we have also not seen any of the packets that has been dropped. Then what to do? We have to show the drop figure. Otherwise, somebody will think like that it's not working. It's not at all working. So here, whenever only 3 nodes will be there, this is a problem which arises always. So now what we'll do? We'll go back to our program. Gedit TCL. We'll go back to our program at this particular stage. Means back here, I will do it 0.1, and I will make this still more, some 700 MB. Now we'll see again it will drop or not. And animation also we have not seen, that's way. Now NS prog1 dot TCL. Now press this, click here. This I run like that. Not opening again. Just if you want again, 1 minute. Uh, if you want again, run a WK file. Yes. Again, it's telling 0. So go back. Sorry. Close this. Go back to the program. That is my intention. Yeah. Go back to the program. Go with 1000. Yeah. 1 MB, 10 milliseconds. Save this. Close here. Run. Control C. 1 minute. Edit back. Size 50. 10 years. Run again. In a last program, we'll check. Then you can understand at least. Run again. Dropping now. You can see that. That's dropping. Yeah, it's dropped. Now we'll check whether packet our AWK is correct or not. Back here. Yes, 11 packets dropped. Now you start from here. That is what is the value we have taken. First you note down in your observation, that is what is the value you have taken now. So that is 1000 MB, 0.1 MB, that you have to keep in your minds. See, when I varied this particular queue size, automatically, so well, you can now take a conclusion that queue size, how important it is. Now your queue limit I increased in N0 to N1 and I reduced here. So then automatically packets are stopped even though not within a bandwidth. Now you take the values like this, same values you note down. The change you have to note it down. This is very much important. The queue size we are setting to 50 and a 10 and the bandwidth is 1000 and 0.1. What is the next thing? Queue size you fix it, you make it 1500, let it be 0.1 only. We will check still how much packets will drop. Now again run another time. This in observation also, one value you have to show, next you have to show the other value. Now you have to run again NS. Yes. Now maximize this. You can take this, means not making fast, you can do this, but no time, that's why just dropped. You can see the packets are dropping. Right. Now a lot of packets dropped. And close this. Control C. Note it down. Control C afterwards. Then again AWK. Press enter. Again here also 11. Note it down. No change. Within 500 MB, no change at all. Imagine within 500 MB, no change. So this is a thing. How fast the net is working. The number of packets again dropped is only 11. So make a note. Now again you go back for a third value. Again you can check it out. Now for a third value you give around 2000. Then you check again. So you will get things like this. You can do some 2-3 times and you can note it down in observations. Any doubt here, you can ask me now. Either you feel easy or not. Come on, answer me. Answer me. Hello.
Yes, sir.
NSG is easy, no?
Yes, sir.
Automatically TCL script it will generate, but where to put the drag and drop of nodes that links taking a values you must take correctly. If you take correctly, then definitely your code will be correctly and you can run easily. And awk is easy. Awk means not more steps are there in this awk. See how simple it is. So prog1 dot awk, just I will show you. They have asked for drop column number one if it is the count increase. Otherwise, just a simple concept. So you can do this, I think. Now, if those who are having a VMware with you, please practice this program. Those who are taken from Shashi sir, definitely NSG will be there in that. So even Java will also be there in that. This I have taken from my Shashi sir only. Everything is there here as one particular pack. So if you want this image, I can send. But this image itself is 2 GB. How I can send? That's a big problem for me. Anybody have an idea to send 2 GB? So I can send.
So from Google Drive you can send, sir.
So I will send only this image. VMware you have to install. Why? Because
Yes, sir.
VMware it's not a licensed one I am having. I may get problem. So this what I will do RAR file of this image. Are you getting? I will do a RAR file of this image and I will put in a Google Drive. Okay, and I will send you the link where you can get that. Okay.
Yes, sir.
Okay, ma. Thank you. Today now
Thank you, sir.
you attend other class. Thank you very much for attending this particular class. Any doubts is there, you can ask me. Any doubts? Huh? Any
No, sir.
doubts? Okay.
No, sir.
Thank you very much. Thank
Thank
you.
you, sir.
Thank you, sir.